So this last method of volume is based on that whole nesting surface area idea, right? And so if we could take one shell, one outer layer, and the outer layer is shaped like this, and if we unwrap that outer layer, if we slice it vertically and unwrap it, it turns into a rectangle, where the height of the rectangle, the dimension is preserved, but the circumference, which is 2 pi r, which was wrapped around the base of your shell, is now spread out horizontally as the base of your rectangle. And so if we could take that surface area and accumulate a whole bunch of surface areas, we would have three-dimensional volume. So it's a similar idea to what we were doing before. 3D volume comes from the summation of 2D surface area. And in order to be exact, how many such surface areas would we need? Okay, infinitely. Okay, infinitely many of those surface areas that were infinitely thin. And then we would have an equivalency to the 3D volume. Okay, so our volume is going to be the integral from A to B of the surface area. And we decided that the surface area of a rectangle is base times height with respect to the x-axis. So we're really looking at altogether from A to B, the base, which is 2 pi r, times the height, dx. And so you're, again, setting it up into a formula. Once you have that, then it's just the plug and chug of doing the antiderivative. Okay. The way this is set up is under the assumption that you were centering this around the y-axis, but we have to account for the possibility that this volume that we're trying to find is not necessarily centered around the y-axis anymore, around that vertical. So we have to take that into account. All right, so let me show you how to account for that. It's where it happens in what the radius is. So 2 pi. The radius has to account for the axis of rotation. So the radius is going to be the x value minus the alpha value, alpha being the axis of rotation. The absolute value means it doesn't matter if your axis of rotation is on the right side of the origin or the left side of the origin. This will take care of it for you, and you don't have to worry about where that position is happening. Because otherwise I would have to say, well, if it's on the right side of the origin, then you can do x minus alpha, but it's on the left side, you'll have to do alpha minus x, and if you just do absolute value, you don't have to worry about it. Okay? Now the height, again, that height is assuming that the height is going from something down to the x-axis. Well, what if the height doesn't go all the way down to the x-axis? What if the height stops away from the x-axis? So we have to account for that as well. And so the height could be y2 minus y1. Now a lot of times that y1 value will be 0 because you're going all the way down to the x-axis. Lots of times that will be true, but sometimes there won't. So the radius completely matches up with the absolute value of x minus alpha. That's, again, accounting for the axis of rotation. And the height completely matches up with y2 minus y1. Many times the y1 value will be 0. Many times the axis of rotation will be 0. And when those are 0, great, it makes the problem easier. But we do have to account for the possibility that it's not 0. Oh, it is dx. Thank you. I had it written right the first time, and then I changed. I don't know why. I think I wrote y, and my brain just changed it. Okay, so d, oops, x. Okay, so let's do some problems. So this is called the shell method or the nesting method. Okay, rotate. Y equals rad x and y equals 0 on the interval 0 to 4. Around, and we're going to do it twice. So we're going to do part A, we're going to do it around the y-axis. And then B, we're going to do it around the line x equals 6. Just for practice, to see how it changes or doesn't change. So square root of x, y equals 0, and up to the interval 0 to 4. All right, so let's get an idea of what this looks like. So square root of x is that half parabola that's going sideways. Y equals 0 is the x-axis, and I'm going up to the number 4. So here's my region. And I'm rotating that over. For the first time, we're going to do it over the y-axis. So when I rotate that over the y-axis, I'm going to come over here, and my shape will end up looking like this, but it does have that cone shape coming out of the middle, out of the center, sort of a funnel coming down. All right, if I'm thinking of this as shells or nests or layers, and if I peel off the outside layer, and then I peel off the next layer, and I keep peeling layers as I work my way toward the center, what's happening to the heights of all the layers? They're getting smaller. The heights of the layers are getting smaller because as you're working from like right here as your height, and then you're tracing this path all the way down, the heights are getting smaller as they decrease. They're following the height of the rad of x, and that's going to be decreasing. So the height does not stay the same. The height is changing each time. So we're going to use the nesting or shell method. By the way, this is a method that works awesome around vertical axes. Doesn't work so great around horizontal axes. You got to convert everything into different variables, and so if you're around a horizontal axis, stick with the methods we were doing before. All right, this is just a better way to do it around the vertical. Okay, so let's set up our volume. All right, our volume's going to go from 0 to 4. It's going to be 2 pi, and then we need to do radius. And we need to do height, dx. So for this problem, the radius is the absolute value of x minus the position of the axis of rotation. And what's the axis of rotation right now? The y-axis was the axis of rotation, so that value was 0. Okay, because that's the equation for the y-axis is 0. The height is being formed by my y1 minus y2, which is rad x minus 0 dx. So that's the tricky part, is getting that set up. Interval 0 to 4, 2 pi, then the absolute value, and then the two heights, which happen to be 0. One of them happens to be 0. So let's clean this up a little bit so that I can do the math. I'm going to pull 2 pi out to the front. I'm going to have absolute value of x, and I'm going to have rad x. So once I've simplified this, now you ask yourself, are the absolute value bars, do they continue to be necessary? Not no because it's volume. The answer is no because the region, my bounds, are 0 to 4. Is there anything I could plug in there that would require me to need absolute values? No, because 0 to 4 is a positive interval. So because of the positive interval, I can drop my absolute value. And because I could drop my absolute value, I can multiply x times rad x. And what is this goes back to basic algebra. Okay, the multiplication becomes x to the 3/2. And then that is a super duper easy antiderivative to do. And now I'm on the home stretch. Antiderivative will be x to the 5/2 times the fraction 2/5 plus the value of c, going from 0 to 4. And then I'm just going to evaluate that antiderivative. Okay, I'm not going to finish that because that's not the point right now. Okay, any questions on that? Okay, same region. Now we're going to rotate it around the line x equals 6. So same shaped region. Okay, interesting. Where is the line x equals 6? It's out here. Okay, there's the line x equals 6. So when I rotate it around that, I'm going to have a really different looking shape. Whoa. Okay, yeah, it's like, oh, yesterday Tom called it a half a bagel. It's like the top half slice of a bagel. Okay. All right, so there we go. It's rounded, but it does have this cylinder bored out of the center. So it's a totally different shape, but we're going to use the same strategy to find our volume. Our volume is still 0 to 4 because that is the boundary of the original region. Your bounds are not 0 to 6. Okay, 6 will come into play when I use my axis of rotation. The bounds are still 0 to 4 because that was the original region we're starting with. All right, 2 pi, the radius, times the height. So 2 pi RH dx. Okay, so my radius, absolute value of x, minus 6. The height is the square root of x minus 0 still. So we need to simplify this. So I'm going to pull my 2 pi out to the front. Okay. All right, so we are at 6 minus x, and then the rad x dx. I hope I convinced you. If I didn't, stick around during break and I can convince you some more. So we want to clean this up. And we want to distribute. And so I'll have 6 rad x minus x to the 3/2. And I will take the antiderivative of those two to complete. I'm not going to finish that. Okay, that's not the point. I just wanted you to see the difference of doing an absolute value. Okay, last one. Different region. So I want the region now to be a parabola, 3x minus x squared, and a line, y equals half x. So parabola is upside down, and the line is intersecting it. The bounds are going to be from 0 to 5/2. Okay, around the equation, x equals 4. So we are looking at a parabola that has a common intersection at the origin and then intersects like that. So that's the shape. It goes from 0, 0 here, and the intersection point here is 5/2, comma, 5/4. So we are going to take that region and we're going to rotate it around the line x equals 4. And the line x equals 4 is over here. So we're going to get a funny, and really, you don't have to be a great drawer, and you don't have to be able to draw this perfectly to be able to see how this is going to go. This is really like a bundt cake.
Like a slice.
Yeah, it's like with the.
Someone took a funnel out of the bottom.
Yeah. All right. So my drawings leave quite a bit to be desired, but all we got to do is make sure we know how to set it up. All right. So our volume. We're good on our bounds being 0 to 5 halves. We're 2 pi. Okay, we need the radius. So absolute value, x minus 4. Very good. Okay, now the height.
3x minus x squared.
Nope.
Minus,
Yeah, we're not squaring anything. We are doing y2 minus y1. And so I did have a y2, which was the parabola, and I did have a y1, which was the line. And then that would be dx. And so then we would clean this up. Y2 is the upper, yep, the one that's higher, the higher of the two, compared to the y-axis. Compared to the x-axis. All right, so we can pull 2 pi out to the front. All right, we need to look at the absolute values. Is it good the way it is, or does it need to be changed? Needs to be changed, because any number within that interval would cause the absolute value to be negative, so I need to look at 4 minus x. And then in the interior, when I subtract, I'm going to get 5 halves x minus x squared. So that is the calculus is finished pretty much. I needed to do the algebra of understanding absolute value, of subtraction. What's my last algebraic step before I'll go back to calculus again? I need to FOIL so that I can take the antiderivative of each piece. So when I FOIL, okay, 4 times 5 halves of x, that's 10x, minus 4x squared, minus 5 halves x squared, plus x cubed. And so then I would simplify like terms and integrate each piece, and then plug in for my my bounds. So again, I'm not going to finish that. That's not the point today. The point was learning how to set up the nesting or shells method. If they have you in your book, in your homework, some that are going the other way, it is possible. You just have to switch everything. Everything would have to be in terms of y instead of in terms of x. Or go back and just do the old way we've been doing for the last 2 days, using pi r squared, r minus the axis of rotation squared. Yeah.
They're not always going to give us bounds in this problem, are they?
You might have to find the bounds on your own. The intersection points. Yep.